Hello, this lesson is about similar triangles and also about dilations and similar figures. So I'm going to start with the title of the lesson, which is Similar Triangles, and then we'll talk about some vocabulary terms. So let's start with similar. Similar means you've got figures that are the same shape but different sizes. Okay, and also the angle-angle similarity theorem states that if two pairs of corresponding angles in two triangles if they're congruent, then the triangles themselves are similar. Okay, so let's look at a couple of examples that deal with dilations and with similar triangles. So here's the first example. Line segment JK is 10 centimeters long. Let's pretend this is JK. And it's dilated to form line segment J prime K prime with a scale factor of 0.3. Now if the scale factor is 0.3, that means that this figure is going to actually end up being smaller than what you started with because 0.3 is less than 1. So we're just going to take the scale factor and multiply it by the original number we started with. So we're going to do 10 times 0.3, and you'll find that that equals 3. So the answer is the line segment is now 3 centimeters. Okay, so mathematicians are kind of obsessed with triangles and with circles. And today's lesson has a lot to do with triangles. So if you have two triangles and you're trying to determine if they're similar, for two triangles to be similar, all three corresponding pairs of sides must be proportional, and two corresponding pairs of angles must be congruent. So you've got two choices. You can either, to show that two triangles are similar, you can either show that the sides are proportional or that two angles are congruent. And we will show an example of how this works. Okay, so first, the question is, are these two triangles similar? Well, first, look at them. Do they look like they're the same shape? Yeah, they do, but they're different sizes. So maybe they're similar. First, I would look for the smallest measurement from both of these triangles, which is 1.62. And on the other triangle, the smallest measurement is 4.56. Those are called corresponding sides because they go together. So this side and this side are the same side, it's just this figure has become smaller. Okay, they're corresponding. The next largest number is 3.59. And on this triangle, it's 7.18. These two sides are corresponding sides. And then the last number, and these are corresponding sides. GP and BC are corresponding sides. So once you've identified that, you can set up some fractions to determine if these are proportional. So I'm going to take 4.56 and divide it by 1.62. And this is my little fraction here. Maybe I'll switch to purple. 4.56 divided by 1.62. That should be equal to, I'm going to take 7.18 and divide that by 3.59. And that should be equal to the same number I get when I take 7.38 and divide it by 3.69. So what I need to do is I need to take a calculator and find out what I get. So 4.56 divided by 1.62 is 2.814, and it repeats. 2.814, and it repeats. When I divide 7.18 by 3.59, I get 2. When I divide 7.38 by 3.69, I get 2. So I found out that 2.814, excuse me, is not equal to 2. All three of these ratios should be equal if I have similar triangles. So my answer is no, triangles are not similar because all three sides are not proportional. Okay, so for letter B, I cannot answer if the triangles are similar, or I cannot answer the similarity statements because the triangles are not similar. Okay, we have a couple more examples. Example 3 is asking the same question. Are the triangles similar and why? Okay, so I see this marking here. It's called an arc mark. And it shows that angle C and angle B are congruent. I also have these two congruent angles here and here. I'm going to put 2 arc marks because these are vertical angles. They're congruent. So now that I have 2 pairs of congruent angles, I can say that the triangles are similar. Yes, because 2 pairs of corresponding angles are congruent. They're similar because I've got 2 pairs of corresponding angles that are congruent. The triangles are similar by angle-angle similarity. So since the triangles are similar, I can write a similarity statement. And I'll say triangle A, B, C is similar, it's a little squiggle sign, similar to triangle A, B, C. A has no markings on it, and neither does E, so A and E are corresponding angles. E, and then B has one marking, and so does C, E, C, D. Okay. The order of these letters actually matters. Okay. On example 4, the last example, it says the figure has been dilated. Which of these statements is true? So what you actually need to do is look for a proportional relationship. This is what we just did, but it's asking the question another way. So if there are prime symbols on the bottom, on the denominator of the left, there should be prime symbols on the denominator of the right side. Same thing with this one. There should be primes on the denominator here if they are over here. Okay, C might be the answer. There should be primes over here if that's the answer. So this is showing me a proportional relationship. This small side, this large side divided by the small side is equal to this, where is BT? BH and BT. That might be an error. BH and HT is what it should say. Looks like there's a mistake here, unless I'm crazy. This will still work though. So out of the answer choices, this is the best answer. Okay, and then let's look at the practice. So the practice says, are the triangles similar and why? If they're similar, write a similarity statement. So what I need for you to do is I need for you to pause the video and try these on your own before you watch me explain them. Alright, so the first one, I need to figure out they're similar. The first thing I'm going to do is mark these vertical angles and say they're congruent. The second thing I'm going to do is look for another pair of angles that are congruent, and it's actually not possible because of this angle 36. There's no 36s over here, which means I cannot have two pairs of angles that are congruent. So the answer is no, the triangles do not have two pairs of corresponding congruent angles. And then on question 2, I have 3 sides on both of these. It looks like I've got the smallest number is 5, and it matches up with 4. The next largest number is 6, and it matches up with 4.8. And then the last number is 8, and it matches up with 6.4. So I can make my 3 fractions 5 divided by 4, and I'll also have 3 divided by 6.4, and I'll also have 6 divided by 4.8. And when I do that, I'm going to get 1.25 for all of those. Let me make sure. Oh, this isn't a 3, this is actually an 8. Okay, yeah, I'm going to get 1.25 for all 3 of those ratios, which means the answer is yes, the triangles are similar because all 3 corresponding pairs of sides are proportional. All right, thank you for watching.